Following his famous experiment, Rutherford proposed his own model that basically aimed to describe the structure of the atom, and this model became known as Rutherford's model, or the planetary model of the atom. Now, in this model, the atom basically consists of a very tiny but concentrated region of positive charge that became known as the nucleus, and surrounding this nucleus are orbiting electrons, which essentially have a negative charge. Now, he argued correctly that most of the atom consists of empty space, and he said that approximately 99.9% of all the mass of the atom is found within this nucleus. Now, he said that the electron actually stays in orbit around the nucleus in the same exact way that our planets stay in orbit around the sun. That is, the velocity of the electron is always perpendicular to the attractive electric force between these two regions. Now, Einstein was later able to use Brownian motion to essentially estimate the diameter of this particular atom, and he found that diameter is equal to about 10 to negative 10 meters. Now, as it turned out, this model, the planetary model of the atom that was proposed by Rutherford, was partly inaccurate, and that's because of the following two important reasons. So, let's begin with reason or flaw number one. Now, this model basically failed to explain why individual atoms produce discrete spectra of visible light. According to Rutherford's model of the atom, when electrons accelerate in orbit, they should produce electromagnetic radiation with a wide range of frequencies, and that basically means that individual atoms, according to this model, should produce continuous light spectra. However, experiments show that individual atoms do not produce continuous spectra, but rather they produce discrete light spectra. And we'll talk more about this when we discuss light spectra of atoms. Now, let's move on to reason number two, or flaw number two. So, according to the planetary model of the atom, the electron accelerates around the following orbit, and that releases electromagnetic radiation, that releases energy in the form of light. And this can be explained using Maxwell's theory of electromagnetism. So basically, as the electron accelerates, it continually releases energy in the form of light. Now, by the conservation of energy, if the electron loses energy, that means it loses kinetic energy. So the kinetic energy of the electron should continually decrease, and that should continually decrease the velocity of that electron. Now, with a decrease in velocity, the electrons would not be able to stay in orbit around that nucleus. In fact, they would spiral into the nucleus as shown in the following diagram. Why? Well, because as it moves around, it loses energy, it loses velocity, and so the orbit becomes smaller, and it basically follows a spiral path and eventually will hit the nucleus, and the atom would essentially be destroyed. So this implies that atoms are generally unstable. Now, we know this is not actually true because atoms are mostly stable. For example, the reason that I'm standing here and giving a lecture is because I'm able to exist as a result of the stability of atoms. So atoms are in fact generally stable. And this basically tells us if the planetary model of the atom is correct, then atoms are in fact generally unstable. And so this means that the model cannot actually be a true depiction of what the structure of the atom looks like. So these are the two flaws that basically disprove Rutherford's model of the atom.